Good afternoon, dear students. We were learning about the Bosch functions of the SLIC, that is the subscriber line interface circuits. So, based on the level of voltage that is required for the operation of the different functionalities in the SLIC, it is divided into two groups. So, I'm just giving a brief information about what we had discussed yesterday. That is, low voltage groups are nothing but, what are they? Low voltage groups are your supervision, your codec and the hybrid, and the high voltage groups are your BOT, that is battery, over voltage protection, the ringing and the test circuits. Okay, this is about the Bosch functions of the telephone system. Next, we will just have a quick recap of what we have, what are the topics covered as part of the unit number 1 of the telecommunication, the title of the subject, communication systems. So we had the introduction about the telephones, the basics of telephone system, and we have learned in detail about the internal circuitry and components of a standard telephone and the local loop. Then later on, we moved to the electronics telephone and the detailed internal circuitry and components, and what are the different functionalities of each and every component we have learned for standard telephone and the local loop as well as the electronics telephone. Next, we started with the cordless telephones and what are the different frequency allocations that has been allotted for the different cordless telephones. That also we have learned. And later on, in the previous class, we had learned in detail about the Bosch functions of the telephone communication. So before moving further to the telephone facsimile, the paging systems and other topics, let's have questions for a discussion. As I have shared you already yesterday, I have shared some questions so that you have a look into it. You should have a quick glimpse of the questions, there is answers to the questions. And let's have look into the different questions, and we'll quickly go and try to find out the answers for the questions. So define specifically what is meant by the local loop. So these are the questions. Now let us see in detail one by one. So these are the questions which we had discussed yesterday. Okay. Totally 16 questions were there. So we will see one by one. So sir, can you enable the chat box, sir? Yes. So what is the first question? Define specifically what is meant by the local loop. Please post your answers in the chat box. Okay. So I'm receiving answers. Very good. Twisted pair of cable connected between the telephone, connection between the telephone and the twisted. Yeah, very good. Very good response. I'm getting answer from Lohitya, Abhirami, Nachiappan, Madhu Tarun, Sri Sahadia, Chaitanya Venkat, Sunil Verma, Chakravarti. Yeah, very good. Agalya. Register number 112, 197. Swarup has raised hand. Do you have any questions? Post in the chat box. Yes. Okay, ma. Thank you. Thank you for your responses. Now let us see what is the exact definition of a local loop. So the local loop is the subscriber loop or a two-wire twisted pair connection between the telephone and the central office. So this is the exact definition of a local loop. Many of you have answered. I appreciate your involvement here. Thank you. So the local loop is the subscriber loop. It is nothing but a two-wire twisted pair connection between the telephone and the central office. Okay, now let's move on to the second question. What type of power supply is used to power the standard telephone, and what are its specifications and where it is located? Answer to this question. What type of power supply is used to power a standard telephone? What are its specifications and where it is located? Please post your answers in the chat box. DC supply, minus 40 voltage. Very good. Kavya has answered. Anjali has answered. It is located at central office. Very good. Mohan Sai, Pranita, Kirti, Shalini, Reshmi, minus Rupika, minus 48 volt DC is very good. Karthi, Yes, Kavya, Mohammed Taisuf, Lohitya. Okay, very good, ma'am. Thank you for your responses. Many of you have answered correctly. Yes. Okay, ma'am. It is a DC voltage supply located at the central office. Very good. Thank you so much. Okay, now let us see what is the exact definition. So the type of power supply used here is DC voltage, as many of you have mentioned. So the central office applies the DC voltage over the twisted pair line to the telephone. So the DC voltage applied here is approximately of minus 48 volt with respect to the ground in the open circuit condition. That is, it is located, the central office, and the central office only supplies the DC voltage to the telephone instrument using the via the twisted pair of connection. Okay, so the level is minus 48 volt. Okay, thank you so much. So next we will move on to the next question. Third question. State the characteristics of the ringing signal supplied by the telephone company. State the characteristics of the ringing signal supplied by the telephone company. What is that? Can anyone answer? So just you have to, when they ask the characteristics, means just you have to specify the level of the signal, the voltage level of the signal, as well as what is the frequency range of the signal. So when you talk about the characteristics of any signal, you should be talking in terms of its frequency and the voltage level. 60 to 105 volt. Suresh, RMS 20 hertz is okay, that's correct. Suresh has answered. Suresh Reddy, register number 244 has answered. RMS 20 hertz, that's correct, but not 60 to 105 volt. Yeah. Anybody? 6 to 5 volt. Okay. Any other person? RMS 20 hertz voltage, that's correct. 6 to 5 volts is the voltage drop that is occurring across the circuit. Okay, now let us see the answer. RMS 20 hertz is correct. Okay, now let us see the answer. Okay, what it is? So the ringing signal, it is 90 VRMS AC signal, and it is approximately at the frequency of 20 hertz. So this you should have it in mind. So whatever you have mentioned here is 6 volt is the voltage drop that is occurring across the circuit whenever the handset is lifted up. So that is the 6 volt. So don't get confused with that. The actual ringing signal, it is going to be of the level 90 VRMS AC signal at the frequency of 20 hertz. So have this in mind. So I wanted you to go through the material whichever is being shared in the LMS, as well as this general information. I'll share it soon. Hereafter, I will also share the video lecture, whatever is being recorded here, so that it will help you to learn in detail. You understand? So the ringing signal here, it is of the level 90 BRMS signal, and it is approximately with the frequency of 20 hertz. Okay, so that is the correct answer for the third question. Let's move on to the fourth question. So which this is most of us are familiar with. What is a hybrid? What is a hybrid? Post your answers in the chat box. Yes, it converts. Shravanti has answered very quickly. That is, it converts 2-wired and 4-wired from the bidirectional audio. It converts 2-wire and the 4-wire form of bidirectional audio. Okay, it permits, Pranita has answered, it permits full duplex communication. Very good. Jennifer has answered 2-wire circuit to 4-wire. Yes, yes, it is a special type of transformer. Anjali has answered. Suresh has answered. Nachiappan, Mohammad Nausuf, Khavya Damni. Yeah, Yana Galya, Hema, Jitin Venkat. Yeah, very good. So that is the purpose of hybrid. Okay, convert 2-wire to 4-wire. Yeah, thank you. Many of you have answered. It's number 85, 703, 187, 135. Pradeep, Mohan Sai, Rashmi, Rinath Reddy. Yeah, very good. So now let us see what is the exact definition of a hybrid. So the hybrid is a special transformer, as most of you have told the answer. Very good. It is used to convert the signals from the four-wired line of the transmitter and receiver in the handset to a signal suitable for a single two-line pair to the local loop. Okay. And this hybrid permits a full duplex communication, that is the simultaneous send and receive communication, that is an analog communication on the two-wired line. So that is the functionality of hybrid. Okay. Somebody has raised hand. Jaya Prashant. Have any doubt? No. Okay. Okay. Now let's quickly move on to the next question. Fifth question. This many of you have answered yesterday itself. True or false? Most of the telephone companies can still accommodate pulse dial tones. Is it true or false? Yesterday itself, most of you have answered. Yeah, it is true. Still, they can accommodate pulse tone dialing system, but with the invention of all the digital and advanced electronic telephones, they are not frequently used. Okay, but still they can accommodate pulse dial tones, but we are not frequently using that with the invention of other things. Somebody has answered for the other question, the coming question, Shravanti. Okay. Okay, now let's move on to the next question. So the answer here it is true. Okay, let's move on to the sixth question. What is the type of transmitter or microphone is used in a standard telephone and how does it work? Shravanti has answered to this question in advance. Shravanti, yes. What is the type? It is going to be the carbon granule transmitter. That is going to be the microphone. Yeah. Transducer that converts the sound energy into the electrical energy. Very good. Nandini, Suresh, Sunil Verma. Yes, carbon microphone is used. Harini Devi, question number 80. Srinath Reddy, Anjali, Jagadish, Mohan Sai, Vaishali. Very good. Yes. Very good, very good. Thank you for your responses. So let us see what the exact answer is. So the microphone uses a common element, as all of you have told. It uses a common element that effectively translates the acoustical vibrations into the resistance changes. Acoustical vibrations means whatever we speak, the modulation of the speech, that is called to be acoustical vibrations. So that is affecting the resistance present there. So this resistance changes in turn produces the current variations in the local loop representing the speaker's voice. Okay, so it creates a modulation. The vibrations creates the modulation of the vibrations that we speak is affecting the resistances. So the changes in the resistance produces the current variations in the local loop representing the speaker's voice. That is how our speech, there is a voice signal, is converted into the, what is that? Speech signal. Okay, so the resulting AC voice signal produced on the telephone line is approximately of the range 1 to 2 RMS value. So this is the voltage level. Okay, do you understand? So this is about, you should not forget in your lifetime. So you might be thinking, so these are all the older technologies, why we wanted to know. But these are the basics of the electronics. So that we should have it in mind. We should understand the basics. So without learning A, B, C, D, we cannot, alphabets, we cannot go on directly write the words or any phrases of sentence. We should have the basics. So that is why, even though many of the technologies, whatever we have learned, are not used nowadays, but these are the basics of electronics that we should have a clear understanding. So it helps you to understand the basic concepts of electronics, whatever you are learning in your, whatever you have learned in your previous semesters. Okay, so that is the intention for understanding these concepts. Okay, now let's quickly move on to the next question. Define what is meant by the tip and the ring and state the colors used to represent them. Please answer to these questions in the chat box. What is meant by tip and the ring? The tip is green and the ring is for red. Very good. And what does it represent? So that is going to form the twisted pair cable. Okay. Two conductors on the sides of the telephone. Many of you have responded. Yes, very good. Okay, okay. Thank you for your responses. Okay. Now let us see what the answer is. So the two wires used to connect the telephones are the tip and the ring. The tip wire is green in color and it is usually connected to the ground, and this you should have it in mind. The tip wire is green in color and that is usually connected to ground, and the ring wire is red, which is actually going to carry the voltage signal. You understand? So this is about the tip and the ring. So these are the important terminologies that you should have in mind. Okay. Now let's quickly move on to the next question. What is the name of the touch tone dialing system present in the telephone system? Dual tone, multi-frequency. Yes, very good. It is going to be a push button, but it is going to follow the dual tone, multi-frequency. That is the DTMF. Very good. Yes, Najmus Shekhar has answered. Revati, Sonali, Chandupavan, Reshmi, Hemant, Ritvika, Mohammed. Yeah, many more to tell. Okay, thank you, Mohan Sai, Samarsiva. Okay, thank you for your responses. So now let us see, that is the DTMF. Okay, next we move on to the next question. When two tone frequencies are generated, what is the two tone frequencies generated when you press the pound key, that is the hash key on the touch tone phone? Please post your answers. This question yesterday somebody asked. Yes. So it is going to be, yeah, Shravanti has answered. It is going to be a combination of 941 to 1477 hertz. Okay, so it will be linearly coupled and that is transmitted. Yeah, very good. Yes, 941 and 114. That is the dual tone multi-frequency. Yeah, correct. Yeah. So whenever this question is asked, you should have a quickly, what do you call, the DTMF keypad. Okay. And then you have to tell the answer. So now let us see what the answer is. Yes, many of you are answering it correct. Very good. Very good. Okay. So whenever this question is asked, you have to immediately recall this DTMF keypad. So what is the hash button? Where is the hash button located here? It is located here. So the low group frequency is 941 hertz and the higher group frequency here it is 1477. So whenever this particular keypad is pressed, that is key is pressed, that is if number hash is pressed, the two sine waves are generated simultaneously. One is at the frequency 941 hertz and the other is at the frequency 1477 hertz. And these two signal frequencies are linearly mixed. So that the combination of these linear frequencies produces a unique sound, and that is easily detected at the and recognized at the central office, indicating that the signal representing the particular frequency is the dialed digit hash. So this is how they differentiate the numbers that is being pressed by using these keypads. Okay, the same is the case for your advanced electronic telephones, even your touch pads, touch screens. Okay, the same method is used in an advanced level using the digital technology. Okay, so this is about the touch tone phone. So do you understand this concept where whenever a particular key is pressed, these low group frequencies and the high group frequencies, they will be linearly mixed and they'll be producing a unique sound that will be identified by the people at the central office or the machine at the central office, indicating and identifying whatever signal is pressed. So this is about the touch tone phone. Okay. So now let us thank you for your responses. Very good. I appreciate you, every one of you who have answered. Next, we'll move on to the next question. What is the name of the building or the facility to which every telephone is connected? What is that? What do you call that? Yes, telephone exchange or central office. Very good. Very good. Either Ramalakshmi, answer in the public, that is to everyone, not to me privately. Yes, Hemalata, Ahalya Reddy, Manikanta, Pavitra, Suresh, Trinath, Narsimha Reddy, Dilip, Sai, Shruti. Yes, very good. Very good one. Little Angela, Amrudavalli. Yeah, very good. Okay, so it is the central office or the telephone exchange. Normally we call that. Okay, so what kind of microphone is used in the electronic telephone? So what is the type of microphone used in the electronic telephone? So previously we discussed about the standard telephone. Now we are talking about the electronic telephone. What is that? Can anyone answer? Let's type broadband microphone. Microphone type. What do you mean by MEMS? This we had discussed in the class. Broadband. I'm getting only the carbon microphone. Carbon microphone is used in the standard telephone, standard analog telephone. I'm talking about the advanced electronic telephone. Okay. Okay, now let us see what the correct answer is. So it is going to be the electret. It is going to be the electret microphone, not the carbon microphone. Okay, there will be some kind of crystal oscillators. They will be producing the sounds. So that is going to be the electret microphone. So you should differentiate. So in the standard telephones, they used the carbon, the molecules or granules as the vibrating material for the microphones, whereas in case of electronic telephone, it is going to be the electret microphone. Okay. Now let us quickly move on to the next question. What is the purpose of the bridge rectifier circuit at the input to the connection of the telephone to the line to the telephone company? Bridge rectifier circuit. Yes? Bridge rectifier circuit. Do you recollect the rectifier circuit, bridge rectifier circuit, which is located at the point where we are connecting the tip and the ring to the telephone exchange office, and here we have the ringer circuit, the voltage regulator. Please recall this electronic telephone circuit. Okay, now let's quickly see the answer, what it is. What is the purpose of bridge rectifier circuit? So both the voltage levels that is coming from the telephone exchange, that is the 48 volt DC, that is on 220 hertz ringing voltage, will be applied to this bridge rectifier circuit. So it is going to be the in path of the electronic instrument, telephone instrument. So for the direct current, the bridge rectifier provides the polarity protection of the circuit. So that direct current will be applied from the means of this 48 volt DC will be applied from the telephone exchange. So it is going to act as a polarity protection for the internal circuitry of the telephone instrument, ensuring that the bridge output always is positive, because we receive a minus 48 volt DC from the telephone exchange. So that should be rectified. So it always provides a polarity protection for the internal circuitry of the telephone instrument, as well as whenever the AC ringing voltage is applied, this bridge rectifier rectifies into a pulsating voltage. Therefore, it converts the AC ringing voltage that is coming from the telephone exchange to a pulsating DC voltage. So that is the main functionality of the bridge rectifier circuit that is available at the initial position of the connection of the tip and the ring to the central office and the telephone instrument. Okay, do you understand this point? So this is the functionality of the bridge rectifier circuit. Okay, now let us quickly move on to the next question. Name one type of low-cost sound device that is used to implement the bell or the ringer in the electronic telephone. What type of instrument is used here? So for the previous question, some of them have answered. Suresh, Mohan Sai, Sheikh, Meghraja, Kishore, yeah, many of them have answered. Piezoelectric sound element is going to be a buzzer. Yes, very good. So you may be knowing the answer by recalling the topic, whatever you have heard. Even you can search in the whatever material you have, you can search an answer. We wanted you to be attentive here. That is we wanted you also to involve in the class. That is the intention of having a question discussion in the class. Buzzer. Buzzer is the general terminology. I wanted you to be more technical. low-cost sound device. Yes, piezoelectric sound element. Now let us see the answer. So it is going to be an external crystal or a ceramic resonator. So something you told, piezoelectric sound element, it is something similar to that. So it is going to be a ceramic resonator or the external crystal oscillator that is going to provide the ringing sound whenever this ringing voltage is being applied to that particular circuitry. It will be producing the ringing sound. That is going to be the sound element. Okay. Let's move on to the next question. Say true or false. In an electronic telephone, the hybrid is a special type of transformer. So this most of you are familiar with. So let's see the answer. It is going to be true. Is it not? So it is going to be the transformer, special type of transformer that will be converting the 4-wire line to the 2-wire line. Very good. So this most of you would answer. Everyone would answer. Somebody is waiting. Okay. Now let us move on to the next question. Last but one question. Give two names of designations for the standard connector used on telephones. Standard connectors used on telephones. Jack plug. Yes, very good. Very good, very good. Shruti, Reshmi, Sai, Shrutik, Jagdish. Yeah, but give specifically. Yes, yes. Venkata Reddy has answered. RJ11 plug connector. Yes. Varshita, Suresh, Dhamini, Thamarai. Yes. Pavitra, Manikanta, Sunil, Najyapan. Yes, very good. So it is going to be the RJ11 modulator connector. So it is going to be the RJ11 modulator connector. It's a subscriber interface, also known as the wiring block or the modular interface. So these are the other designations or the names given for that particular RJ11 modulator connector. Okay, thank you. Thank you for your responses. Let's move on to the last question. So this is the term which we have seen in the last class. State the 4 frequency ranges used by the cordless telephones and tell which type of modulation is used. Let's see how you're answering. State the 4 frequency ranges. So it is been allotted, the frequency has been allotted by the FCC, Federal Communications Commissions. No, this 5,000 and 7,000 are the range of coverage of signals. I wanted you to tell the frequency allocation range for the cordless telephones. You recollect 900 to megahertz to 928 megahertz? Yes. 2.4 gigahertz. You recollect? Yes, 900 to Suresh. Suresh has answered 43 to 50 megahertz. So it's in the range of megahertz. Yes, Prithvika has answered this correctly. 43 to 50, 900 megahertz, 2.4, 5.8 gigahertz. Yes, very good. Okay, now let us see in detail. So the FCC, the Federal Communications Commission, has set aside 4 primary frequencies, that 43 to 50, 902 to 928, 2.4 to 2.45 gigahertz, and 5.8 gigahertz. And the type of modulation used here is analog phones use FM modulation, whereas the digital phones use the Gaussian FSK modulation and the direct sequence spread spectrum technique. So yesterday, some of you have answered and raised a question for what do you mean by frequency shift gain. I hope you are familiar with frequency modulation. Please unmute yourself and tell me what is frequency modulation. Can anyone answer?
To increase the strength of the signal.
That is the purpose of modulation. Santosh, thank you for your answer. So that is for increasing the strength of the signal. I'm asking what is meant by frequency modulation. How do you perform? Muhammad Imran?
By changing the frequency.
Yes. How? Which will change the frequency? Sricha, Badya, can anyone who knows the answer can unmute? How do you perform modulation? So the purpose of performing modulation is to increase the strength of the signal. Okay, combining the higher frequency in the message signal. Sandeep has answered. So there will be a message signal, the data that we are going to transmit, and there will be a carrier signal. So based on some parameter, we will be performing the modulation. With respect to frequency, yeah, Veera Ramalakshmi has answered, changing the frequency with respect to change in the amplitude. Yeah, very good. Rutvika also has answered by varying the instantaneous frequency. Yes, Jagadish, you need to wanted to answer. Jagadish, question number 127. Okay, sir, you can unmute that, sir. So, based on some parameters, if it is going to be based on what is that frequency, it is going to be frequency modulation, and if it is going to be amplitude, it's going to be amplitude modulation, and the phase modulation. So, I wanted to just show you. Yes, how this FSK is happening. Chat box, you will disable. Let me share another presentation. Are you able to see, sir? Yeah. So this is about the FSK. So in normal frequency modulation, amplitude modulation, and the phase modulation, which you had studied in the earlier semester in the analog communication subject, it is going to be analog in nature. There is both the message signal as well as the carrier signal. It is going to be analog in nature. So whereas here in the frequency FSK modulation, see, you see, so modulating signal, the data, it is always going to be digital in nature. So it is something similar to the frequency modulation as you're performing in the analog for analog signals. Only difference is that the data or the modulating signal will be digital in nature. And we call that as frequency shift keying. So this is a simple diagram that explains how these FSK signals are being modulated. That is here, you see, this is the logic one. So it is going to be zeros and ones. So the digital PML, we all know that digital signal, it is going to be either 0 or 1. So that is going to take the modulating signal or the data. And we have the sine wave as the carrier. So this logic 1 signal, it will have the different frequencies. Okay, and logic 0 will follow the different frequencies. So you see the output side. So this is going to be the message signal or the modulating signal, and this is going to be the carrier signal. And this is the output signal, that is the modulated signal, that is the FSK modulated signal. So the frequency is going to vary for the level of the modulating signal. So it is going to have higher frequency, it is going to have lower frequency. So this is how it is performed here. So this is a picture that clearly explains how the frequency shift keying method is implemented. Okay. So another diagram. So this is some of the digital modulation techniques that normally used for digital signals. So this is going to be the digital or the message signal, and this is the carrier signal. So if it is going to be amplitude modulation, the amplitude of the modulated signal will be varying. You see, for one, that is the modulating signal 1 level, it is going to have, this is the amplitude, and for 0, it is going to have a lower amplitude. It is going to be Vmax and minimum. Here we are going to calculate. So this is how it is performed. So this is again for 1, it is going to have a higher amplitude, and for 0, it is going to have a lower amplitude. And for frequency shift keying technique, so the frequency is going to vary. For 1, it is going to have a higher frequency signals, and for 0, it is going to have a lower frequency signals. Similarly, for PSK, that is the phase shift keying signal, it is going to change in the phase. You see, this is for 1 modulating signal. So there is a change in the phase of the signal. So that is the different, the digital modulation techniques used for digital signals. The same as the modulation we perform in case of the analog signals. Only difference here it is the message signal or the modulating signal, it is going to be digital. digital image. You understand this concept? So this is what is used in the cordless telephones. Okay. So now let us come back to the yes. Okay. So this is about the different topics that we have covered yesterday, and one more important point before going to the next telephone hierarchy, I wanted to share you some quick little video clipping that is going to explain how the wiring is done for the modular jack connector, how to give the ring and the tip connections. Quickly go through it.
Hey everyone, welcome back to Do It Yourself Telecom. In this video, I'm going to cover wiring a household or residential phone jack. So this is not for business, this is for residential, and particularly is applicable in the United States. So you usually have about 3 types of jacks in a house. You might have a surface mount, or in the industry, in slang, we refer to this as a biscuit jack. You can have a wall mount jack, which means this sits on the sheetrock and then a phone sits on top of it and slides down. So if you think about a kitchen style phone or grandma's phone in the kitchen that would sit on top of that on these 2 little stubs right here. The last type that I don't have right here in front of me is a flush mount jack, which looks a lot like this, except instead of having these little posts on it, it's just flush into the sheetrock. So there's usually like a rectangle hole in the sheetrock, and then there's the screw holes that the flush mount goes into. The nice part is that the wiring concepts are the same regardless of which type of jack you have. All right, so on these these biscuit jacks or surface jacks, there's usually some kind of like a little spot where you can stick a screwdriver and pry it open. If not, you can kind of stick a little knife or something in there to kind of, basically it's just an interference fit. So all you're trying to do is just kind of pop that cover off of there. Inside, you will see the 4 different screw posts.
You see here, so we have the ring and the tip connection here. And if you wanted to connect, so the, what is that? Black and yellow for the extension line, additional telephone line connection you wanted to have, you have to give that connections. So now let us see.
And there's a red, green, yellow, and black. Now you may see a couple more, like you might see like a blue and a white, that's okay. What we're concerned about mostly is just the red and green. And here's why. Most of your residential wire in the United States is this kind of tan or maybe a beige or like a gray.
With the
and
material,
it's what we refer to as drop wire, or also category 1. And it's just got 4 conductors inside. So I'm going to strip back the jacket on here. And by the way, these things are called snips or electrician scissors. You don't necessarily need these to get this job done, but you do want to get this cable jacket off of here. You want to peel off about 4 inches. Then inside, here's your 4 conductors. So the nice part is all we're doing is just matching the colors. So if you only have 1 line in your household, then you're really just concerned about red and green. All right, if you want to go ahead and hook up yellow and black, that's fine too. If you do have 2 lines, then it may be using the yellow and black also. That's the way it usually works. Line 1 is red and green, line 2 is yellow and black. So what we have to do now is within these conductors, they've got like a little bit of plastic sheath on them, so we want to peel that back. So I'm going to peel off about 2 or so inches of the plastic sheath to reveal the copper. Then on my screw post, and this is true for this type or the flush mount, you'll see it on the flush mount on the back, but like on these, there's a little spot where you can kind of pry off the cover, and you'll see inside, it's got the screw post inside, see? It's got the same screw post inside. All you're doing is just matching the colors, that's all we're doing. So you want to, the best practice is generally to put enough of the cable inside the jack so that the cable jacket or the tan part is well into the middle, and then you're just taking the wires you just stripped, loosening up your post, maybe like 1 or 2 full turns. You don't need to take the screw out, so don't take the screw out. You just want to loosen it up, because then you create a gap and you just wrap that bare copper portion of the cable around it like this. All right. You don't want to have a bunch of like extra bare cable behind it. You want to have it so it's just about almost all the way up there. So see how my red plastic sheath is pretty much up to where the screw starts, and you tighten it down. And of course you got this slack. You don't want to leave that. You can either kind of wiggle it until it falls off, or if you've got a pair of little cutters, you can just cut off that little slack, because you don't want that slack in there. Okay, we don't need that. We don't want that floating around inside the jack, shorten things out. And then repeat the process for the green, and you can repeat the process for the black and the yellow as well, if you want to, or if you need to.
That is for the green.
And you don't have to wail on these. I'm sorry, you don't have to really cinch down on these screws real hard. You know, just maybe 2 or 3 pounds of torque is fine. All we're trying to do is just get the copper to be pressed up against that screw, and the other little there's like a little metal fork in there that connects to the green wire inside the jacket. See how I just kind of wiggled it off until it broke off? All right, if you're not going to use these, you can either just cut them, or you can loop them up and just stuff them inside here like that. And that way, in case somebody needs to come back and use those pairs, I'm just going to cut them off right now. All right. And then you want to put your cover back on, and you're done. Now, if you need some more of this wire, you can get it at most hardware stores. It's referred to as like household phone wire or just phone wire. However, what you do not want to use, and I absolutely cringe when I see this, is don't take one of these, what we call line cords, and cut the end off and try to use those wires inside. You're just asking for trouble. It doesn't work well. Can you make it work? Yeah, maybe, but it's not a good practice, and it usually causes more problems than it's worth. Get real phone wire. All right, same idea applies to wall mount and also to surface. Now, if you happen to have commercial wire inside your home, which could be common for homes that were built in.
So the one which was you have seen earlier is the residential wire, and this is going to be the commercial wire. That will having more number of telephone lines.
The last 15, maybe 20 years, you're not seeing the red, green, yellow, and black, but instead you're seeing something like this: blue and white, orange and white, green and white, brown and white. Then what you want for line 1, if you just have one line in your home, is you want, or one phone number to your house, then you want the blue and the white. The white goes on the green post, the blue goes on the red post. And if you have 2 lines, then on the orange-white pair, the orange-white goes on the black, and the solid orange goes on the yellow. All right, so if you have this, all you're going to do is just match the blue-white pair, the white to the green, and then the blue to the red. Same principles apply though, as far as the way you handle the wire, strip the wire, etc.
That is about.
All right, that's really it. It's just about that simple, and I hope that helps you out. Thanks for watching.
So that is about the wiring techniques here. So before moving on to the telephone hierarchy of the next topic, so now I hope you have had a clear glimpse of how the wiring connections are being done. So that is the RJ connector, to which we'll be connecting the telephone instrument using that wires. And internally, you have to give connections in such a way. And if there is any wear and tear goes off in the wiring connections, you should be in a position to rectify it. So that is about the telephone connections. So here, I have created a poll kind of thing to answer to some of the questions. So I'll be soon launching the poll to you here. Please answer to the questions here. Okay. So I'm just going to launch the poll. So it's going to have only 5 questions of, it's kind of objective type questions, which we have, on the topics which we have covered so far. Yes, everyone is asked to participate, and the report will be taken based on that for attendance as well. So each and every one of you, I want each and every one of you to participate in this poll. So I'm using this poll facility in Zoom for quiz kind of thing. Okay, soon we'll have another quiz that will be conducted in Kahoot app. I think most of you are familiar with Kahoot app, because last semester itself we have conducted quiz in Kahoot app during the last semester. I think for you, some of the sections have also participated in that. Okay, so I'm quickly launching the poll. I want each and every one of you to participate in that. It's going to be a 5 objective type questions. Okay. Please answer to these questions. I want each and every one of you to participate. Soon we will discuss the answer for that questions. Please make it fast. Okay. Thank you for your responses. That's the end of today's session. We'll meet you with another topic in next class.